All right, welcome to another exciting episode of Advanced Level Chemistry here at Spain Park. Today is Thursday, October the 17th, 2024. And today we're going to really learn about how to do mole calculations. On Tuesday, we've had just kind of this crazy stretch here of days off and testing and whatever, but we got to kind of pull it all together. So on Tuesday, we started talking about the mole. And if I have a mole of something, how much do I have? 602 sextillion, or easier, 6.02 times 10 to the 23rd. Now, there are more digits out there. Some 6.022, but it goes out even more, 4, 5, 6, 7 more places out there, okay? But it's just like a dozen. That's how much is in a mole. So if I have a mole of donuts, I have that many donuts. If I have a mole of marbles, I have this many marbles. If I have a mole of anything, I have this many of anything. Okay? But we can't count. That number is way too big to ever count. So instead, we have to get a relationship between that and the mass. And so we have this thing called the molar mass. That's what we were talking about on Tuesday. This is left on the board from Tuesday. Now, the molar mass is an umbrella term for elements. We have the atomic mass. You just get that's the red number on the periodic table. And I found that this periodic table and the one that you have, some of the numbers are slightly different. And it just happened because I just opened up this new packet of periodic tables for you. I've been using this same one for 40 years. But for the first time, that yours is slightly different as far as the atomic weight, which means they must have found a different percentage in the earth and had to modify, because remember we do the average atomic weight is a percent based upon the abundance. So if the atomic weight changes, the only thing that's changing is the percentage. They must have found that, hey, it's slightly different percent as they go and dig around the different parts of the world and combine data and all that kind of stuff. So we got to double check. So far it's only been zinc is the only one that's been slightly different that we found. But the atomic mass is on the periodic table. But if it's a covalent compound or an ionic compound, we're going to call it the molecular mass. If it's ionic, it's going to be called the formula mass, because technically they don't form molecules, but we're really going to calculate these in the same way. Now on Tuesday, did we talk at all about how to calculate the molar mass or the molecular mass? So let's do that. How do we calculate that? So I would say, what is the molar mass of H2O? Okay? What is the molar mass of H2O? Well, in one mole of H2O, how many, well, in one molecule of H2O, how many hydrogens are there? Two. So if I have 100 molecules, how many hydrogens do I have? 200. Okay? So if I have a mole of water molecules, how many moles of hydrogen do I have?
2.
1 mole of water contains 2 moles of hydrogen plus how much oxygen do I have?
1 mole.
1 mole of oxygen. Is everybody with me on that? So if I want to get the mass then of a mole of water, what do you think I do? Add them together. The molar mass of H2O is going to equal 2 moles of hydrogen times, what's the mass of each mole of hydrogen weigh? And how do we find that out? You look at the atomic weight, and y'all, it probably would behoove you, aka greatly benefit for ACT words, okay? It would behoove you, greatly benefit you, to get your periodic table out so you can just kind of follow along and see these numbers rather than trying to always point up here. But if I look on the periodic table, Ryan, can you see what hydrogen's red number is?
Yeah.
What does it say?
1.00794.
1.00794. Well, we're always going to go, you can put all those down if you want to, but I usually round to 2 decimal places. Okay? So I'm going to say 1.01 grams for every 1 mole. So that's the weight due to hydrogen, and hopefully we can do this mental math here. So what's the total weight due to hydrogen? Come on. 2 times 1.01.
2.02.
2.02, okay? We did the mental math. So we got basically 2 grams of the water is due to hydrogen. Well, how much oxygen do we have? 1 mole of oxygen. And what's the molar mass, the atomic mass of oxygen? You see on your periodic table, what does it say?
15.16.
Well, it's 15.9994, right?
Yeah, so 16.
So let's just always round that, and you're going to use it over and over and over again. That's 16.00. Okay, so that's the weight due to the oxygen in the water. So the total weight is going to equal 18.02, and the units are always grams per mole. So if I have 18 grams of water, I have 1 mole of water. Because 1 mole contains all of that. So that means that if I take 18 grams of water, which the density of water is 1, so 18 milliliters is 18 grams. So I have 18 milliliters here. So how many molecules of water are in here? How many molecules are in here? What did we just figure?
1 mole.
1 mole. And how many molecules are in a mole? 602 sextillion. So in this 1 18 milliliter sample of water, I have 602 sextillion molecules of water, give or take a few trillion. Okay? So I can now, there's no way on God's green earth I can count those molecules, but because I have the molar mass, I can have a relationship between how much it weighs versus how much are actually in there. Okay, because the reactions all take place in terms of 2 hydrogens combined with 1 oxygen. It's not 2 grams combined with 1 gram. But there's no way to count, so having the mass gives us a way to know how much is there. Okay? So calculating the molecular mass is pretty easy. So if I just said, what is the molar mass of glucose, C6H12O6? How would I do that? We can kind of shortcut it. What am I going to do?
6 carbon.
Okay, so what do I do with that, Mars?
6 mole.
Okay, I'm going to say I'm just going to go 6 times what?
C times.
It's number 6.
12.01.
12.01. Okay, and she looked and you know she was just finding carbon on the periodic table. Then she found the red number is 12.01.
Over 1 mole.
That's all right, but I'm going to show you the shortcut here. This is the long units and whatever, but this is the way we're going to do it real fast. Okay, so 6 times 12.01. That 6 is that 6, and 12.01 is the atomic weight of carbon. So what's next? Plus 12 times what?
1.01.
1.01. Is everybody right? 1.0079. We're just going to round to 1.01. Now, if you want to put 1.0079, you can put 1.00794 if you want. I'm going to say 1.01. Plus what? 6 times 16.00. All that turns out to be 180.18. So if I have 180 grams of glucose, how many molecules do I have? 602 sextillion. I have the same number of molecules as water, but this is a much bigger molecule, right? So if I compare my piles of molecules, even though we got the same number of molecules in each pile, this pile is going to weigh more because it's a much bigger molecule. So this tells me then, it gives me a relationship between how much there is in the weight in terms of how many molecules there are. Does that make sense? So we have 2 conversion factors now. We have Avogadro's number, that is atoms per mole. So if I want to go from atoms to moles or moles to atoms, I'm going to use Avogadro's number. So if you see a conversion, if I have atoms, I know I'm going to use this 6.02 times 10 to the 23rd. If I have grams and moles, then I'm going to use this molar mass. And the only thing that's different between an element and a compound is an element, I find it directly on the periodic table. A compound, I got to add them up. And it doesn't matter if it's a covalent or ionic, we do them exactly the same way. Okay, and we're going to practice the sheet that I just gave to you. We're going to practice all day today, all day tomorrow, and you have a test on Monday. Okay? So this is kind of our roadmap here. Atoms to moles, we use Avogadro's number. Moles to grams, we use the molar mass. We can go either way. But can we go directly from atoms to grams? No, we got to go through moles. Moles is the common thing in both of the conversion factors. Moles is the hub around which all chemistry revolves. Okay? All right, so let's look at the sheet then that I just gave to you. This is your time if you have any questions on how to do this. Well, we'll go this, do this. Do you want to leave that up there? Let's see. I don't know if I'm going to be able to keep that there or not. All right, now the good news is that this sheet gives you practice. It gives you examples of exactly what you need to do. It's just kind of what I just went through. All right here is how to set things up, go from atoms to moles and from grams to moles. Okay, so you got that. So I am going to erase all this. You have that all written down. If you didn't write it down, well, you have it right here. So if I'm looking at this, and I want to go, what is the mass of 1.75 moles of zinc atoms? I want to clarify something. You take English so you can properly read a good science problem like this. Okay? What is the mass of 1.75 moles? So it's asking for the mass of this many moles. The of zinc atoms, what's the grammatical, what is this? It is a prepositional phrase describing, it's used as an adjective, describing what moles we're finding. But it's just, we're not finding zinc atoms, we're finding moles of zinc atoms, right? So you got to make sure that you don't let this atoms mess you up, because we're not going to use Avogadro's numbers here. We're not looking for atoms, we're looking for moles. Okay? That's why we learn how to read and break things down and know, what the object of the sentence is and all that kind of stuff. Okay? So, what do we start with? What's our given?
1.75 moles.
1.75 moles. Now you can put zinc, Zn, and I'm looking for the mass. Mass is going to be what unit? Make sure we know that this is grams. Okay? So what's my conversion? I have two conversions. Atoms to moles, grams to moles. Which one do I want to use?
Grams to moles.
Grams to moles. So where do I find that number? And this is the one here. Mine says 65.39, but yours says 65.41, right?
Right.
Okay, so where does moles need to go?
On the bottom.
On the bottom. So we're going to do the exact same thing. We learned how to do dimensional analysis in the beginning of the year so we can really apply it to this. Whatever's on the top here has to go on the bottom there, so it's going to be 65.41 grams over 1 mole. Moles cancel. I'm left with grams, which is what I want. So what do I do to those two numbers?
Multiply.
They're both on top, right? We multiply. And to 3 sig figs we get? Anyone? 114. And we'd say grams of zinc. Huh? They're all the same size. Okay? You have two conversion factors only. Atoms to moles with Avogadro's number, grams to moles with the atomic mass off the periodic table. So what do we do? What would we do on this one?
You would start with 42.
42 grams. And it's going to be of aluminium. So what do I know has to go on the bottom right here?
Grams.
Grams. What's the only conversion factor that has grams?
Grams to moles.
Grams to moles, the molar mass, right? So you go to the periodic table and look up aluminum.
26.98.
What's the next number?
1.
981? Okay, because they said 99 in the last class. But 26.98 grams, and it's always 1 mole. It's always 1 mole. So what am I going to do with those two numbers? I'm going to divide them. Again, the 3 sig figs.
1.56.
5, 6.
Yes.
Wouldn't that be? Oh, points.
That's moles of aluminum. Because 1 mole is 26.98, so I have 42, so I know I have a little bit more than 1 mole. But see, again, this lets me know if I have this many grams, now I know how many actual atoms or molecules are there, because I can know how many moles there are, and I know how much in each mole. So try to do C. Just do C right there on your own. So probably one that's different. All right, so somebody on the second row, anywhere across, tell me what we did.
Start with 0.675 moles.
Okay, times
63.55 grams over 1 mole.
63.55 grams over 1 mole. And where'd you get me in? Where'd you get that number from?
The atomic mass
The
on the
atomic weight on the periodic table. Does everybody know where those numbers are coming from? Okay? How do you know which one to put on top, which one to put on the bottom? Whatever's on top here, it's got to go on the bottom there. That's why we learned dimensional analysis. So hopefully it's had 9 weeks to kind of sink in, and now it's just, oh yeah, it all comes back to me now. Both on top, so we multiply them here, what you get?
42.9 grams of copper.
Are we all good with that? Pretty straightforward, right? Not too heavy math? All right, so now look at D. Does everybody have this so I can move it up? Does everybody have it all copied that needs it? Going once, going twice? Everybody got it? All right. So now when we go to the D, how many atoms now are in 1.5 moles? So I start with 1.50 moles, okay, of carbon, but now I want to go to atoms. Just doesn't say, you know, of atoms, I want how many atoms. So what's my conversion factor between moles and atoms? Avogadro's number, right? So where does moles need to go again? So what goes on top? That number, 6.02 times 10 to the 23rd atoms over, and it's always 1 mole. Moles cancel. Now this is why you have to, again, relearn how to use your calculator with scientific notation. We did all that in the beginning because we knew that I knew that this was coming down the pipe. Okay? This is the important part, being able to do this. This is fundamental chemistry right here. And it comes out to 9.03 times 10 to the 23rd atoms of carbon. And just for units, and especially guys, this is what I want to see. Okay? This is how I want you to do it. Learn how to be neat. Learn how to be systematic. If for all else, learn how to do it my way so you get a good grade. But I promise you, I'm not just trying to make you do extra work. It's going to help you. All right, so see what you do on E. Cross. And when you're doing scientific notation on your calculator, you probably want to use parentheses. Okay? Just make sure you remember how to do that.
Oh, yeah.
Okay?
You're so ready. You're so ready.
Yeah. I think. Like y'all's calculators probably use. So when in doubt, use parentheses. You do.
Why'd you,
All right, now once again, we spent forever learning how to use our calculators with scientific notation and how to go through all of this. So you need to know, I'm not spending any more time going over your calculator, how to put it in. Okay, you've got to figure out your calculator. So, but if atoms is here, what has to go here? And that's going to be what number? 6.02 times 10 to the 23rd atoms. Doesn't matter what the substance is, Doesn't matter where, and that's supposed to be atoms of iron. Steve. Okay, and it's always gonna be 1 mole. And because atoms will cancel, leaving us with moles of iron, and what number does that come out to?
0.1.
Okay, so some of y'all are getting 0.0125 moles of Fe. Others of you are getting 1.25 times 10 to the minus 2 moles of Fe. Are those two different answers?
Same.
It's the exact same number. It's the exact same number. Y'all, you gotta realize scientific notation, regular notation, it's the exact same thing. It's not a different number completely. Okay? Exact same number, both 100% correct.
I just don't care which one you do.
Okay? Now notice again, I was given atoms, so I know that my conversion factor has to have atoms, and that's the Avogadro's number. So now let's turn the page. So now, this is where so this is now, we have atoms to moles to mass. Okay, this is what I erased from earlier. Okay, to go from atoms to moles is what we've just been doing, using Avogadro's number. The first ones where you go in moles to mass and mass to moles using the molar mass. But we don't have a direct conversion factor between atoms and moles. So what does that mean? You gotta go to moles first. Okay, moles is the common thread in both of those conversion factors. So it's going to be a 2-step problem versus a 1. So again, I start with 1.25 times 10 to the 24th atoms of nitrogen. Because I'm given atoms, what do I use? Atoms on the bottom, and what number? That's Avogadro's number. 6.02 times 10 to the 23rd atoms. What goes on top? 1 mole. Okay? So atoms stop and I'm left with moles, but I don't want moles, I want mass, which is grams. So what do I do next? Molar mass, and I know that because moles is here, I know I'm gonna put 1 mole there, and what number goes on top? The atomic weight from the periodic table, 14.01. So what am I going to do to these two numbers? Multiply or divide? Divide, and then multiply here. This is again where you need to use parentheses. This is why we have to know how to use your calculator. Using the calculator is not supposed to be the hard part here. Make sure we know how to enter all this in on the calculator. Do we have a number? 29.1. Is everybody getting 29.1?
I've got 2.99.
29 point, you got what?
2.91.
Okay, yeah, that's probably how you put this in
Yeah.
on your scientific notation. And I always want an answer with a unit and a label, grams of nitrogen. Okay, so again, figure out your calculators. Now let's take 10 minutes, 8 minutes, and see if you just do G, H, I, and J. Just finish that page. Take roll.
I did. It did not work. I tried twice.
Lead is PB, baby. But lead is PB.
Yeah, just this.
You have a C, you have times 10 to the first of it.
Oh. Okay.
So you're just in scientific mode. So you gotta just, you always gotta pay attention to that out there.
If you have any questions, feel free to ask me. All right. If you haven't finished these, you can finish them. You can just kind of copy here, but how many atoms are there in 18 grams? So I know I'm going to start with 18 grams of silicon. So since I have grams, what has to go here? Grams. So what's the only thing with grams in it? The atomic mass. So you go to the periodic table and you see silicon, it's going to equal 28.09. And then he's on the bottom, 28.09 grams, 1 mole. That gets me to moles, it doesn't get me to atoms, which is what I'm looking for. So how do I go from moles to atoms? So I'm going to say 6.02 times 10 to the 23rd atoms over 1 mole. And all that's going to turn out to equal
3.86 times 10 to the 23rd atoms.
times 10 to 23rd atoms. Okay? Now, just to save time, okay? I'm going to go, you can go through and work all these, but let's get to, what did we get for H? What's the answer? Okay, you guys got to speak up.
0.215 grams.
0.215 grams
PB.
of PB lead. And then this one, how many atoms are there?
8.13 times 10 to the 21st atoms.
Of
NEs.
any neon. And then lastly, HIJ,
0.923 grams.
0.923 grams of, which one? Silver, AG. All right? Does anybody have any questions on any of those? They all kind of follow the same process, right? We only have 2 conversion factors. So whatever's on top, start with what's given, set your units up so they cancel. It works all the time. That's why I told you at the beginning of the year, it's one of the most important things we're going to learn all year long, because it's going to see us through almost all of the problems that we continue to do. Start with what's given, find the appropriate conversion factors. This time we have 2. Avogadro's number and atomic mass. All right, so now we just want to look at, well, what if it's a compound instead of an element? Well, everything is exactly the same, except using the word atom, we're going to use molecules. And when we go and use the molar mass, we're going to have to add them up instead of just being able to get it. So it's an extra step of calculating the molar mass. But again, it's just adding them up. So let's look at this first one here. And then tomorrow, I'm going to let you kind of finish up the back of the page. But I just kind of want to go through this with you. And so tomorrow, you can finish this. You'll note on the very back page of this is a practice average atomic mass problem. And then there's a chart filling in the protons, neutrons, and electrons like we need to be able to do. Okay? It's kind of like an additional study guide, but then you also can then complete the study guide, doing all that as practice for Monday. All right? So tomorrow we'll be able to work on all that. But here we go. Here we have 15 grams of H2SO4. Okay? A sample of H2SO4. So all of these questions relate to that 15 grams of H2SO4. Now, calculate the number of moles of H2SO4 molecules in the sample. So we're given grams and we have to go to moles. So I have 15 grams of H2SO4. So what has to go down here? The grams. And that grams is called the, in this case, it's not going to be atomic mass, it's going to be molecular mass, so we just use the term molar mass. So I have to get the molar mass of H2SO4. So the molar mass of H2SO4 is going to be, how do I do it?
H.
2 times
1.01.
1.01, which is the atomic weight of hydrogen. That 2 is that 2, plus, how many sulfurs do I have?
1.
And atomic weight of sulfur,
32.07.
0.7. And how many oxygens do I have? 4.
16.00.
And all that together is 98.09 grams per mole. So that's my molar mass. So I had to go and calculate this. So where does that go? So I'm just going to say, now it's going to say 98.09 grams. So do I have a whole mole?
No.
No, I only got 15 grams. A whole mole is 98. You know, I have a little bit more than 15% of a mole. So what do I get?
0.153.
0.153 moles of H2SO4. So now, how do I go to molecules? I know moles of H2SO4 now, so how do I go to molecules? Using Avogadro's number. Times, again, 6.02 times 10 to the 23rd. This time, instead of saying atoms, because it's a compound, I'm going to say molecules. But a mole's a mole, 6.02 no matter what. So it's molecules over 1 mole. And that's going to equal
3.54 times 10 to the negative.
no. We did something wrong. Did you divide it? Did you?
Oh, I accidentally divided it.
Yeah, you
so
divided it. Anybody?
9.1.
Okay, so that's how many molecules of H2SO4 are in 15 grams. Notice they just broke it up into 2 steps. On the previous problems, we went and did it all just in one big long step. Okay, but this is just doing the same thing, going from grams to moles, moles to molecules in 2 steps. But now look at this. How many atoms are there in the sample?
The same as all.
Well, no. How many atoms are in an individual molecule? You got 2 hydrogens, 1 sulfur, 4 oxygens. So in the molecule I have 7 atoms. So if I have this many molecules, how many atoms total am I going to have? This, what? 7 times this. So I'm going to say 9.21 times 10 to the 22nd molecules of H2SO4 times 7 atoms for every 1 molecule. And that number turns out to be
6.45 times 10 to the 23rd.
So that's the total number of atoms, okay? Because molecules are composed of atoms. But now, so let's look at this one then. So what would be the only difference between these two? Find the number of oxygen atoms.
Just multiply by 4 instead.
Say that again, Michael.
Just multiply by 4 instead.
Multiply instead of what?
7.
Instead of 7. There's 7 atoms total, but of the 7, 4 of them are oxygen. So I'm just going to say 9.21 times 10 to the 22nd molecules of H2SO4 times 4 oxygen. And I have to write it out because if I just put O, it makes it look like it's a 40. 4 oxygen atoms over 1 mole. And that number turns out to be
3.68.
atoms
no oxygen.
Okay? So you do the exact same thing. Now you have an extra step here for again, differentiating between atoms and molecules and all of that. But we're doing the exact same thing, we just have to calculate the molar mass. So we went through a lot as far as the math here, but I think it's all making sense because of units. And you just kind of follow along with the units. So tomorrow again, is gonna be much less of me talking and you guys just going through and finishing up this worksheet. We're finishing up, going to practice ones on the study guide, and get any questions that you might have. And then we'll be ready for everybody to make a 100 on the test on Monday. Okay? All right. That's all for today, and go Jags.